Inverse functions. The inverse of f of x, the notation that we most typically are going to see, is f to the negative 1 power of x. It does not actually mean f to the negative 1 power. It means the inverse of x. And the graphs of f of x and its inverse are reflected over the line y equals x. So the line y equals x is this line. I should have used the same color for it in all of these, but I didn't. Right here, that cuts the first and third quadrants in half diagonally there. And if you have inverses, you should be able to fold that graph in half over that line, and the two graphs should match up, right? So here are 3 examples of what that would look like. If we are asked to graph the inverse of a function, I want everybody on that first graph right there blindly sketch in what you think the inverse is going to look like. So you're going to reflect it over. The line y equals x. You can draw that in if you want. So line y equals x. I want you to just, in pencil, preferably, guess at what you think it's going to look like. There. I'm going to walk around and see what our guesses look like. I'm seeing more of you with the right guess than I thought I would. What I'm seeing out of a lot of you is something that looks kind of like this, which is wrong. Now, I have a hard time visualizing what's happening here. Some of you are maybe very good at visualizing this. Some of you may remember what it looked like from Math 3. But what we can do here is if we've got these points here, like this. I'm going to make myself a little table. X, Y. And then I've got the point negative 3, 6. I got the point negative 2, 3. I've got negative 1, 2. I've got 0, 3. And I've got 1, 6. All right. If you want to graph the inverse, it's reflected over the line y equals x. To do that, you switch the x and y's. Okay? So if I switch the x and y's, now I've got 6, negative 3. So this is if I've got x and like f inverse of x, I guess we want to call it that. 6, negative 3, 3, negative 2, 2, negative 1, 3, 0, 6, 1. So switching our x and y. If I graph these points, I'm going to have 6, negative 3, which is here, 3, negative 2, 2, negative 1, 3, 0, and 6, 1. So those of you that had a graph that was sort of sideways like this, which was actually quite a few of you, that's what the graph is going to look like for this problem. Some are pretty easy to see how they will reflect, but I get that slanted line kind of throws me off a little bit, and I have to just actually look at the point. Yes? Yep. Just some people are much better at looking at that like a folding sheet of paper than others, because while I'm pretty sure most people knew that they were like folding that over, they still ended up with it in the wrong spot for that. So I think this is like I think this is something that is sort of, it's teachable with the points for sure. It's kind of unteachable with just visualization. Some people have a really hard time seeing that, and some people don't. There. We'll do the same thing on this next one. We're going to skip it so that we got time to get to some of these others. So, algebraically, if you're given a function, you are going to follow these steps here. So, the first thing that you do is you switch your x and y variables. Now, my f of x, I can treat that like my y, right? So I'm going to switch the x and the y. So I will have x equals 2/3 y minus 5. Okay. Then we need to solve for the new y. Okay. And what we've done there, because like reflecting over the line at y equals x, we switch the x and y coordinates, right? So if we switch where x and y are at in the equation, that has that same effect. So we are going to add 5 to both sides here. So x plus 5 is going to equal 2/3 y. Again, we're trying to solve for that y. How do I get rid of that 2/3? Okay, I like that multiply by the reciprocal. Some of you might be thinking about dividing, which is good. That works, right? But what do we do when we divide? It's easy as pie. We flip the second and multiply. So if we just go ahead and multiply by 3/2, that's the same as dividing, right? So now whenever you do that over here to the right side, make sure you have parentheses around x plus 5 because you are multiplying the whole thing by 3/2. So we're getting y equals 3/2 times x plus 5, like that. And they'll switch back to function notation in a lot of cases. So they'll do f inverse of x equals 3/2 x plus 5. You may see them distribute the 3/2. This is definitely a good answer, but you might see it look like this. F inverse of x equals 3/2 x plus 15/2. Because you're doing 3/2 times 5 to multiply fractions. You got to make that second one a fraction. You just multiply straight across, and you'll get 15/2 for that. So you could see either one of these answers as answer choices. It just depends. If it's free response, you could give me either. I don't know. Okay, here. All right. Next one. We're finding the inverse again. We've got a cubic. So we are going to switch x's and y's. I'm going to have x equals y plus 5 to the 3rd power minus 7. I am solving this for the new y. Evan, what would I have to do first here? I'm definitely going to have to do that, but not first. What do you think, Will? I need to add the 7 first because the 7's not on the inside of that stuff, so I need to get rid of that first. So I'll have x plus 7 equals y plus 5 to the 3rd power. And then I will cube root. So I've got the cube root of x plus 7. If I was doing a square root, I would need a plus or minus. But odd roots do not need a plus or minus because you can take the 3rd root of a negative number. So you just leave it like this, and we got y plus 5. We are almost there. Zane, what should we do last on this one? Trying to get that y right there by itself. Very good. And when we do this, can I subtract the 5 from that 7? I cannot. It's on the inside of a root. I can't mess with it. So we're like subtracting it, you know, over here. So whenever we write it, make sure, I'm going to go ahead and switch back. In fact, let's just go ahead and switch back to G inverse of x. Switch back to G inverse of x. When you write this, make sure you do the cube root of x plus 7, and make sure your 5 is over here outside of the root. If you guys remember doing this sum in Math 3, you should have done it. I realized that was a long time ago for some of us. Alright, now, I don't think you did ones like these in Math 3. And normally I let you struggle with them for a little bit. We only have 5 minutes, so I'm not going to today. So we're going to switch our x's and y's. And so I've got x equals 5y plus 2 over 3y. This is a problem because I need to solve for y, but there's two of them, right? And I cannot solve for y while there's two of them, and I really can't put those together the way they are, right? So if you run into this problem, first of all, you cannot solve for something while it's in the denominator of the fraction. So the first thing I would do here is I would multiply this side by 3y in the numerator, which will cancel out over here, and multiply by 3y over here. So I've got 3xy equals 5y plus 2. Now, can I, subtract 5y? Can I take 3xy and subtract 5y? They're not like terms because of that x, right? So it's not going to be as simple as just, subtracting this over and putting those together. But what you want to do here is you want to move all of your y's to one side. So move all terms with y's to one side. And in this case, I don't have any terms that don't have y's on that left side, but if you had any, you would move them over to the other side. So we got 3xy minus 5y equals 2. Now, believe it or not, we're really close right here because both of these terms have y's. And since they both have y's, I can factor out a y. That. So we can just put y out as the greatest common factor. This is wonderful because now I only have one y. I can solve for that y, right? So this is y times 3x minus 5. I'm going to divide both sides by 3x minus 5. Which will cancel here. So my inverse here is going to be 2 over 3x minus 5. So if you see one of these with multiple y's, particularly a fraction, this is the steps that you want to try there. And I wish we had time to do one more, but it's going to be the same sort of thing.